Uh, this video is going to go more into the inverse trig functions. What we're going to be doing in this video is just kind of just working more complex examples. Alright, so this example may look pretty similar to what we were doing in the previous video for section 7.1. You're asked to find, in this example we have two different functions. Instead of just sine and sine inverse, it's sine and tangent inverse. So what you need to do is first figure out what tangent inverse of 1/2 is. Remember, when you take tangent inverse, or the inverse trig function of anything, that'll just give you an angle. So if you take the tangent of both sides, that means you have 1/2 is equal to tangent of theta. So you need to figure out what angle gives you a tangent value of 1/2. Alright, if you don't know the angles off the top of your head, what you can do is just draw it out on the coordinate plane. Remember, tangent inverse is defined from negative pi over 2 to pi over 2. So it's defined in the first and fourth quadrant. And since tangent is positive, we know it's in the first quadrant. So what we're going to do is find the angle that gives you a tangent of 1/2 using the coordinate plane. Now, and then we're just going to find the sine value of that angle, because after all, we're looking for the sine of whatever the angle we get here. So, if tangent is 1/2, remember that's equal to y over x. So, the y value is 1, and the x value is 2. I don't know why I wrote x, it should be 2. And this is our angle. What we can do is figure out what the hypotenuse is, and then take the sine of this angle. So 2 squared plus 1 squared gives you c squared, because we're using the Pythagorean theorem, so c squared is equal to 5. So if you take the square root of both sides, we have that this hypotenuse is equal to the square root of 5. Because since length cannot be negative, that's why we don't include the negative square root. So now the sine of this angle is equal to opposite over hypotenuse, so 1 over square root of 5. But since we don't like having radicals on the bottom, you can multiply it by square root of 5 over square root of 5. So that just gives you square root of 5 over 5. Alright, so for example 2, it says find the exact value of cosine of sine inverse of negative 1/3. Remember, sine inverse is defined by, it's defined on the interval from negative pi over 2 to pi over 2. So we're trying to figure out what angle the sine inverse gives us and then take the cosine of it. Remember, if we have sine inverse of negative 1/3, if that's equals to some angle, then if we take sine of both sides, we'd have sine of theta is equal to negative 1/3. So, we know sine is negative in the fourth quadrant, because remember our range goes from negative pi over 2 to pi over 2, so that's the first and fourth quadrant, the right hand side of our coordinate plane. And sine is negative in the fourth quadrant, so if we want to draw our triangle, since it's negative, that means since the y is negative in this quadrant, our y displacement would be negative 1, and our hypotenuse would be 3, because it's y over r, or the radius of a circle. So, we need to figure out the x-coordinate so we can take the cosine. So if we want to do Pythagorean theorem, we have x squared plus negative 1 squared equals 3 squared. So x squared plus 1 is equal to 9. which means x squared is equal to 8. And since the x coordinate is positive on the right, since the x values are positive on the right hand side of the graph, when we take the square root, we're looking for the positive square root, so x is equal to 2 times the square root of 2. Guys, remember, we get x is equal to the square root of 8, and 8 factors down to 4 times 2. So our x value is just 2 times the square root of 2. So now that we have the sides of our triangle, we can take the cosine. Remember, cosine of this angle is equal to adjacent, which is 2 square roots of 2, all over the hypotenuse, which is 3. So the cosine value we're looking for is 2 square roots of 2 over 3. So for this example, it says find the exact value of tangent of cosine inverse of negative 1/3. So cosine inverse, remember that's defined on the interval from 0 to pi. So, since it's negative 1/3, alright, let's get this in terms of just cosine first before we move on. If we take the cosine of both sides, we have cosine of theta is equal to negative 1/3. Now that we have the cosine of this angle is negative 1/3, we know cosine is negative in the second quadrant. Because remember, it goes from 0 to pi, so that's in quadrants 1 and 2. Since cosine is negative, that's in the second quadrant. Remember, cosine is just x over the radius. Since the radius of a circle can never be negative, that means the x displacement, let me draw it better. The x displacement is negative, the radius is positive. So x displacement is negative 1, the radius is 3, and here's the y displacement. Now we need to figure out the y. That way we can take the tangent. So if we figure out the y coordinate, that would be negative 1 squared plus y squared is equal to 3 squared. So 1 plus y squared is equal to 9. Y squared is equal to 8. So if you take the square root of both sides, y is equal to, and we already showed earlier that square root of 8 is equal to 2 times the square root of 2. So this vertical part of the triangle, this vertical side is just 2 times the square root of 2. So now we can figure out the tangent. Remember, tangent is equal to just y over x. So tangent of theta is equal to the y coordinate, which is 2 times the square root of 2. Or it's equal to the opposite side, which is 2 square root of 2, all over the adjacent side, which is negative 1. So it's equal to negative 2 times the square root of 2. Now quickly, I want to remind you about the secant inverse, cosecant inverse, and cotangent inverse. You kind of already touched on these already, but I just want to remind you real quick. Alright, so remember, secant, if you have y equals secant inverse of x, that's the same as just x equals secant of y, because remember, with regular secant, whenever you go to secant inverse, you switch the domain and the range. Like the domain of the regular function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. Likewise for cosecant and cotangent. Alright, if you notice, secant inverse and cotangent inverse are both defined from 0 to pi. Cosecant is defined on the same interval as secant, or cosecant inverse is defined on the same interval as sine inverse. So it's from negative pi over 2 to pi over 2. So for this example, you're asked to find the exact value of cosecant inverse of 2. Okay. remember, cosecant inverse is defined from negative pi over 2 to pi over 2. So if we have cosecant inverse of 2 is equal to theta, and if we take cosecant of both sides, we have that 2 is equal to cosecant of theta. Now remember, cosecant is equal to 1 over the sine. So 2 is equal to 1 over sine of theta. So if you multiply both sides by sine of theta, so 2 times the sine of theta is equal to 1, which means sine of theta is equal to 1/2. I don't know why I just circled that, because we're not even done yet. Now we need to find the angle from negative pi over 2 to pi over 2, which gives you a sine value of 1/2. Alright, we know sine is positive in the first quadrant, because remember this interval is in the fourth quadrant and the first quadrant, and sine is positive in the first quadrant. So I'd recommend you go to the unit circle and find what angle gives you a sine value of positive 1/2. Right. And that should be, tell you that the angle would be 30 degrees or pi over 6. And so for this last example in our video, we're going to rewrite this expression, sine of tan inverse of u, as an algebraic expression containing just the letter u. So we're going to figure out a way to get rid of both sine and tangent inverse. But before we do that, let's denote a couple of things. Remember, tangent inverse of u gives you some angle, so if we take tangent of both sides, we end up with tangent of theta is equal to u. Remember, tangent inverse is defined from negative pi over 2 to pi over 2. So, sine of tangent inverse, we said tangent inverse of u is equal to theta, so we can rewrite this as just sine of theta. So now, what we need to do here, see how we have a tangent here? Remember, tangent is equal to sine over cosine, but here we have sine over, that's like, since we have just sine, that's like having sine over 1. So we need to get a cosine on the bottom. But if we multiply the denominator, the bottom, by cosine, we have to do that to the top as well. Because we're multiplying it by cosine over cosine, which is just 1, so we're just multiplying sine by 1, so we don't change the value at all. So if you notice here, we now have sine on top, cosine on bottom, so that would give us tangent of theta times the cosine. Remember, that's equal to tangent. Remember, cosecant is equal to 1 over the secant. So now we have tangent of theta over secant of theta. It may not make much sense right now why we put it as tangent over secant, why we didn't just leave it as tangent times cosine. But I promise you, let me remind you of something you may have learned in trig. And if you didn't take trig, then you might want to write this down. Remember, we have that identity of sine squared plus cosine squared is equal to 1. But we need to get it in terms of secant. So remember, I know secant is 1 over the cosine, so if we divide 1 by We divided everything by cosine squared. We have secant squared of theta equals cosine squared over cosine squared, which is just 1, plus sine squared of theta plus cosine squared is tangent squared. So now if you take the square root of both sides, you have that secant of theta. Since we're solving an equation, we technically look at the positive or negative square root. I'm about to show you in a minute how we figure out which one of these to substitute in for secant of theta. Well, actually, it doesn't matter like what quadrant we're in, because remember, our original angle is given in terms of tangent inverse, and since tangent inverse is defined from negative pi over 2 to pi over 2, that's in the first and fourth quadrant, and since secant is 1 over the cosine, we know cosine is positive in both the first and fourth quadrants, so we want just the positive square root. So if we want to plug this back into our formula for secant, we have tangent of theta is equal to square root of 1 plus tangent squared. Alright, that's why we did that, so we get it in terms of tangent. We want to get it all in terms of one trig function. And there's no trig identity where we could have just substituted into cosine. That's why we didn't just leave it as tangent times cosine, because there's nothing we could substitute in to get it everything in terms of the tangent. And remember, the reason we have it in terms of tangent is, remember, we have tangent of theta is equal to u, so now we can put it in terms of u. Instead of tangent of theta, we have u, and then we have square root of 1 plus, instead of tangent squared, it would be u squared.